In this recording, we're going to solve a quadratic application question using factoring. So I'd like you to find this question in your packet. It's on page 22. And draw a picture to represent this situation to the best of your ability, and then play the recording. So hopefully you took time to pause and draw this picture. Okay, so now that we've got that represented, we can fill in the four panes of the box, or the square, the window, with the values. So fill in those values with their products. Okay, so if you fill those in. Okay, so combining like terms, what do we have? X squared. Combining on the diagonal, this combines to be negative 2x minus 3. All right, but now that's not just the answer, that is the expression. So we're saying this is 21. The area is 21, so we can say equals 21. Now we're going to proceed to solve this because we want to know what's the value of x that makes this true. Well, in order to solve this equation, it has to be equal to 0. So you can manipulate this equation slightly, subtracting 21 from both sides. All right, now we're ready to factor this. See if you can remember how to factor this quadratic expression on the left side of the equation. So we have a 1 here as the value of a. So we're going to multiply 1 times negative 24, the a times the c, make our list for the factors of negative 24. So you might try things like negative 3. Of course, 1 has to be negative, right? But you should be thinking as you're making this list, what do I want their sum to be? Of course, we want their sum to be negative 2. So that doesn't work. Let's try 6 and negative 4. Well, that adds up to positive 2, so we're super close. We just need to change the sign, so we'll make it negative 6 and positive 4. All right, now that we've got those factors, we can create another window to factor this. Now, you don't have to use the window. It's an option, not required. Eventually, we're going to move away from using the window. But I've got x squared, and I've got negative 24, and I'm going to split the negative 2x into these factors, into these terms, negative 6x, 4x. From there, it's pretty easy, right? X and x are the only way we make x squared, and then x times what makes negative 6x? Well, it's got to be a negative 6. And x times what makes 4x? It's got to be a 4. So we've got our factors here, x minus 6, x plus 4. Of course, this is equal to 0, okay? Because it was equal to 0 above. Now we're going to invoke the zero product property. We're going to say, okay, let's say we have a product of 0. This times this equals 0. So that means one or both of the factors must equal 0. Maybe it's this one, or maybe it's this one. Take a moment to solve each of those for x. Okay, hopefully you did that work. So x equals 6. Okay, cool. Or x equals negative 4. Well, that can't be, that just can't be, because if we go back to our original diagram, if x is negative 4, we have negative lengths on our diagram. Okay, I'm going to sort of redraw our diagram over here. We had an x minus 3 and an x plus 1. I might have switched the sides, but it doesn't really matter. Okay, so if x is negative 4, we've got negatives. So we're going to reject that. So let's look at 6. Maybe 6 can be a root. Well, if 6 is a root, that means the top part of our rectangle. I'm not drawing this rectangle very nicely. I'm kind of drawing it like a square. Let me draw it like a rectangle, right? It's clearly wider than it's long. I should have been drawing that way all along. All right, so if it's x minus 3, it's really 6 minus 3, which is 3. And along this side, it's 6 plus 1, which is 7. So I really have a 7 by 3 rectangle. So I'll write what the dimensions are. Okay, because that was what the question asked us to solve. The question said, what are the dimensions? We have found them. 7 times 3 is 21. And it works for this particular setup where x is 6, 6 minus 3, and 6 plus 1. Thanks for watching.